Okay, so let's get started. Okay, hello everyone. This is SeungryongKim. So today we will start the linear algebra. This is lecture 2. So today we will talk about the solving systems of linear equation. Solving systems of linear equation. Today we will talk about what is the systems of linear equation, which lies in the heart of the linear algebra, and we will talk about how to effectively and efficiently solve this kind of the linear equation. Okay. So this is chapter 1.1 of our textbook. So to understand the linear system, I mean the systems of linear equation, we have to start with the linear system, linear equation. So the definition is like that. The linear equation with variable from x1 to the xn can be written as a1 times x1 plus a2 times x2 plus an times xn is equal to which is equal to b, where b and coefficient a1, an can be real or complex number. So this is a general form of the linear equation. For example, if our equation defined like that, x1 times x2 is equal to, or square root of x1 plus x2 is equal to 2. It's not a linear equation. Why? Because of this term. Because these two terms are nonlinear equation. I mean the nonlinear term. So it's not a linear equation. So linear equation should be, I mean the an equation should be represented in general form like this to be considered as a linear equation. Okay, so here's an example. How to draw this kind of linear equation. So first of all, okay, let's suppose that we have x1 minus 2x2 is equal to -1. In this case, we have two variables, right? Two variables, x1 and x2, right? And we have a coefficient, right? a1 is equal to 1 and a2 is equal to -2 in this case, right? Then, how to plot this linear equation? We already know. We already studied this one in your middle school or high school, right? So, how can you do that? First of all, okay, let's suppose that x1 is equal to 0, then negative 2x2 is equal to -1, so it's going to be x2 is equal to 1/2. So here, okay, this x-axis means x1, y-axis means x2, then this point is going to be 0, 1/2, right? What about this? x2 is equal to 0, then x1 is going to be -1, right? -1. So in this case, here, -1, 0, right? So our linear equation can be plotted like this, right? What about this? Let's suppose that we have an equation like the 2x1 plus x2 plus x3 is equal to 6, and we have a 3 variable and 3 coefficient, right? So A1 is equal to what in this case? 얼마죠? A1 is equal to 2, right? A1 is equal to 2, and A2 is equal to 1, and A3 is equal to 1 in this case, right? So when we plot this equation in a 3D space, it's going to be the plane. It's going to be a plane, right? So similar to this kind of technique, we can find out the point lies at each axis. I mean the x1, x2, and x3. So this point should be 3, 0, 0, right? 3, 0, 0, and this point is going to be 6, 0, 6, 0, right? And another point going to be 0, 0, 6 in this case. So the plane that represents this equation, I mean this linear equation, is going to be looks like this, right? So this is a 2D space visualization and 3D space visualization. So this is a linear equation. I guess some of you, most of you already know this one, right? Then, what is the system of linear equation? What is the system of linear equation, which is today's topic? This system of linear equation, also called the linear system. Linear system. This system of linear equation is the collection of one or more linear equation involving the same variable. Same variable. Here's the example. Same variable. Here's the example. Okay. We have one equation, I mean the one linear equation, x1 minus 2x2 is equal to -1, and -1x1 plus 3x2 is equal to 3 in this case, right? So because we have a two linear equation, this system is called linear equation. I mean the system of linear equation or the linear system. It's very easy, right? So one more concept is the solution. One more concept is solution. Solution means the solution makes each equation true statement when the values are substituted for the variables. So for example, okay, so we want to find the solution of this linear equation, then we have to find out the values of each variable, x1 and x2, like this. Okay, so which values, I mean which x1 and x2 make each equation in this linear system a true statement? Which one? 자, 질문 한번 해보면 갑시다. 자, 어떤 x1과 x2 값이 이 두 개 이퀘이션을 true로 만들까요, 여러분? 자, this is just question, right? x1 is equal to 3 and x2 is equal to 2, right? Okay, thank you very much. It's very easy, right? 3, 2 make these two equations true statement, right? How did you find out that solution? How did that? 그쵸? 2를 더해서 2를 더하는 연립 방정식, 그쵸? Right. Awesome, right? So you already know how to solve this linear equation, and this is just today's topic. But today we will see the little bit advanced technique to solve this kind of linear system. Okay. Anyway, so this is the solution, right? And solution set means the set of the whole possible solution. Okay. So in this example, I mean in this linear equation, linear system, the 3,2 is the solution. I mean it's just 3,2 is unique solution. But in some cases, there will be the several kinds of the possibility in terms of the solution set. Okay. So before that, let's talk about how to solve the linear system. How to solve the linear system like this. Because you already know this one, right? Okay, let's focus on two linear equations with two variables, as in the previous example, right? Here, right? The solving the linear equation, the solving the linear system is to find out intersection of the two lines, right? Intersection of the two lines. 강의를 하면서도 이거를 굳이 이렇게까지 해야 되나 싶을 정도로 너무 쉽죠, 여러분? 다 아는 내용이죠? 우리 중학교 때 했던 거죠? Finding the intersections of the two lines by two linear equations, right? So first of all, okay, let's suppose that this is equation 1 and equation 2 here. When x, okay, let's suppose this is x1 and this is x2. When x1 is equal to 0, x2 is equal to 0, 1 over 2, right? 0, 1 over 2 and negative 1, 0 here. We already talked about this one. This is the equation 1. And equation 2 means when x is equal to 0, x2 is equal to 0, right? Maybe here, 0, 1, and when x2 is equal to 0, and x1 should be negative 3. Maybe here, negative 3, 0, 0. So then the plot is going to be looks like this, right? The solution of this linear system here, intersection of the two lines, right? The values of this intersection is 3, 2. We already know, right? This is the way to solve your linear system. In fact, there are 3 kinds of possibility of your solution of your linear system. Okay, let's consider the 3 kinds of linear system. The first one looks like this, second is like that, the third one is like that. Okay, so first of all, let's draw this linear system first. Okay, let's suppose that this is the first equation denoted by red color, and second equation represented by in blue color. And let's draw each equation. So here. So to draw this linear equation, the first linear equation, we first find out the point like this, negative 1, 0, 0, 1 over 2, and looks like this. And to draw this second equation, it's going to be looks like 0.3, 0, negative 3, 0, and 0, 1, and it's going to look like this, right? We already discussed there is one exact solution. So in this case, we say that this linear system has exactly one solution, or just one solution. What about this? What about second linear equation? Second linear system. For example, when we draw first linear equation, it's going to be looks like this, because we already discussed this one. And for the second one, when x1 is equal to 0, x2 is equal to 3 over 2, 3 over 2. So maybe here 0, 3 over 2, and when x2 is equal to 0, when x2 is equal to 0 and x1 it's going to be -3. So maybe here, -3, 0. So in this case, the linear equation is going to look like this. Right? So what is the solution of this case? What is the solution of this case? Where these two lines parallel. So maybe the distance between, not distance, the distance of the values, the x2 values with the same point of x1 should be same in this case. Then in this case, what is the solution of this linear system? 자, 이렇게 두 개가 패러럴이 나오죠? 이런 경우는 뭐죠? 솔루션. 불능 오랜만에 들어보네. 불능. 그쵸? 해가 없죠. No solution, right? Because we don't have any intersection, right? So in this case, we can say that our linear system does not have any solution. So no solution case, right? What about last one? Okay, let's draw the first equation. Negative 1, 0, 0, 1/2, and like this. And second equation, it's going to look like this. There are so many intersections in this case, right? There are so many intersections in this case. So in this case, how many solutions exist? In this case, infinitely many, right? So in this case, we can say that this system have infinitely many solutions. So to summarize, our linear system can have solution set in a three kinds of possibility. One solution case, exactly one solution case, no solution case, infinitely many solution case. So whole of your linear system can be categorized one of them. Okay, then we need to one more concept, consistency or the consistent. A system where the linear system is called consistent if there is at least one solution. At least one solution. So as we discussed in previous slide, one solution or infinitely many solution. Infinitely many solutions. Please understand my typing. 여러분 좀 못 알아보겠죠? 제가 하는 말을 잘 듣고 써주면 돼요. One solution or the infinitely many solution case. So in this case, we say that a system is consistent. Otherwise, if there is no solution case, system is inconsistent. Okay, here's the example. Okay, let's think about first equation and second equation. And when x equal, 그냥 그러면 되겠다. 그렇죠? 0,3, 3,0, x1 and x2 it should be looks like this. And in case of the linear equation 2, it's going to be 0,5, 5,0, and it's going to look like this. Right? In this case, there is no intersection, right? In other words, these two lines are parallel, so we can say that this is inconsistent system, or the system is inconsistent. 글씨가 마음에 안 드네. Inconsistent. 똑같네요, 글씨가. 자, next linear system looks like this. 1 and 2 here. when x1 is, okay, let's draw the first equation. When x1 is equal to 0, x2 should be 0,5. And when x2 is equal to 0, x1 should be 5 over 2. 5 over 2. 그렇죠? 5 over 2, 0. Looks like this, right? And in this second equation case, x1 is equal to 0, x2 should be 0,3. When x2 is equal to 0, x2 is equal to 0, x1 should be negative 1. x1 should be negative 3. 이렇게 되겠죠? negative 3, 0. So our second equation is going to look like this, and we have one solution in this system. So we can say that this system is consistent. Right? It's very, very easy, right? One more concept is equivalence. Two linear systems are co-equivalent if they have the same solution set. If two linear systems have same solution set, two linear systems are co-equivalent, or the equivalent system. Here's the example. Okay, so we have linear system 1 and linear system 2. Okay. Linear system 1 and linear system 2. Let's think about these two. I mean, these two linear systems have same solution set or not. Same solution set or not. Okay, as we've done so far, let's draw the two linear equation. So x1 is equal to 0, x2 is what? 여러분들이 좀 알려줘요. 저도 헷갈리니까. 0,1, 그렇죠? When x2 is equal to 0 and x1 is equal to 1 over 2. So it's going to be 1 over 2, 0. So maybe looks like this. And second equation case, x1 is equal to 0, x2 is equal to negative 5, maybe here. 0, negative 5, and x2 is equal to 2. X1 is 5 over 4, maybe here. 5 over 4, 0. So our looks like this. So, what is the intersection of these two linear equations? What is the intersection of the two linear equations? Who knows? So, 오, 감사합니다. 그쵸? 금방 계산해 볼 수 있죠, 여러분? 저희 푸는 법 나중에 다시 배우겠지만, 그쵸? 1, negative 1 is a solution of this linear system. It's very, very easy, and I think most of you, and all of you, don't need to take this course, right? Because this is very, very straightforward and it's very easy course. Anyway, 여러분들 뭐 너무너무 쉬워서 사실 좀 더 빨리 나가도 될 것 같은데 봅시다. 자, anyway, in linear system 2, let's draw this system. x1 is equal to 0, x2 is equal to negative 2. 맞죠? negative 2. Maybe 0, negative 2. And x2 is equal to 2. It should be 2, 0. 그렇죠? 뭐 여기 이렇게 있겠죠? 2,0. 뭐 이런 식으로. 이렇게 그려주면 안 되는데. 이렇게. 이렇게 나와요. 뭐 답을 정해놓고 그리긴 하는데, 그렇죠? 그리고 when you draw the second equation, and x1 is equal to 2, when x1 is equal to 2, x2 is equal to negative 5 over 3. negative 5 over 3. negative 5 over 3니까 maybe here. 그렇죠? and when x2 is equal to 0, it's going to be 5/2, 0 here. Maybe like this. 여러분 다시 여러분들이 그럽시다. So in this case, anyway, what is the solution of this linear system? I mean the linear system 2. Same, right? 1, -1. So in this case, these two linear system is equivalent. Or it is two linear system are equivalent, or the equivalence systems, right? Or the linear system 1 and linear system 2 are equivalent. Anyway, in this case, these two linear systems are equivalent. Then what about this? When we add it, I mean when we change these three values as 2, then what happened? And in this case, and what if we change this number 5 to the value 4, right? In this case, this one, this flag is going to be moved to this direction, right? Then our new equation is going to be looks like this, right? Looks like this. Then in this case, it's going there will be the infinitely many solution. Only many solutions, right? So in this case, the linear system 1 has the solution 1, -1, and linear system 2 has the infinitely many solution. So in this case, can we say that two linear systems are equivalent? What do you think? Wrong? No? Right. Why? Because these two, I mean the solution set of these two linear systems are not the same, right? 그래서 뭐예요? 이렇게 바뀌면 인피니트메이 솔루션 바뀌었을 때는 솔루션이 존재하지 않더라. 솔루션이 너무 많아져서 이게 결국에는 두 개 이퀴벌런트 하지 않더라라는 거죠. 그렇죠? Any questions so far? Any questions so far? No? 종영 학생 노가 솔루션 없다는 거, 질문이 없다는 거죠? 그렇죠? No solution. Anyway, okay. And we can represent our linear system in a equation form, looks like this, but we can make more effective way to represent your linear system. I mean the definition, which is called the matrix. We can record or the represent linear system in a matrix form, which is much easier to represent your system, and which is much easier to understand your system. So here's the example. Okay, we have a linear system like this, having three equations with three variables, right? Then rather than defining our linear system looks like this. In fact, here is the 0 times x3 plus 0 times x2, right? Anyway, rather than representing this linear system in this equation form, one of the most important part of this linear system is the coefficient part, right? Coefficient here, like this. What if we just record this coefficient looks like 3, 1, 3, 2, and 2, 0, -1, because there was 1, right? And 0, -4, 1, right? It's going to be much easier to understand and more compact representation, right? So in this case, we call this representation as a coefficient matrix. Coefficient matrix. Of course, we can consider right-hand side as well. 2, 5 to 6. So this is the first coefficient for the x1 here, and this is coefficient for the x2 here. This is coefficient for the x3 here, and this is coefficient for the right-hand side. And in this case, we call this matrix as an augmented matrix. Augmented matrix. So this is the coefficient matrix, and this is augmented matrix. This augmented matrix of the system consisting of the coefficient matrix with coefficient matrix, 그렇죠? 그려줄게. Coefficient matrix with additional one column. Additional one column containing the constant from the right-hand side of the equation. 그렇죠? 5 to 6. Anyway, this is the augmented matrix. Oh, 형민? Ah, it's solved. Thank you. Okay, so what is that? Another one? Okay.
아, 그 마이크로 질문해도 되나요?
괜찮습니다. 네.
그 어그먼티드 매트릭스에서 네, 여기서 그 행렬을 사용할 때 위에
네.
어그멘티드라는 말이 없으면은
네.
저 그 행렬 안에 있는 것들이 4개의 x를 나타낸 것일 수도 있는데 그걸 어떻게 구분하나요?
너무너무 좋은 질문이고요. 그렇기 때문에 우리가 이걸 어그멘티드 매트릭스로 이해하기 위해서는 어그멘티드 매트릭스라고 언급을 해줘야 돼요. 그렇지 않으면 말한 것처럼 이게 x1, x2, x3, x4가 있는 그냥 코에피션트 매트릭스로 이해할 수가 있으니까 네, 좋은 질문입니다. 네.
감사합니다.
Okay, it was our first question in this course, so thank you very much. The question was that. Yeah, another question.
Following up on that question, Professor. So if it's not listed as augmented, do we assume that it's a coefficient matrix?
Maybe yes or not. It depends on the question. If we want to, okay, so if the question mentioned that this is the augmented matrix, this last column, I just say the column should be the coefficient, I mean the constant from the right-hand side of the equation. But when the question just say that matrix, maybe it's going to be, this column is going to be just coefficient vector. The coefficient, sorry for confusing vector or the column, just the set of the values for the variable x4. Okay. Any other question? No? Okay. So to understand our matrix, here, okay. So we have to know the size of the matrix, So from now on, we just call matrix. We don't know this one is the augmented matrix or the coefficient matrix, but let's just think about this is just a matrix. And the size of matrix can be represented by the number of rows and number of columns. Okay, so for example, we have a matrix like 1, 2, 3, 4, 6, 7, negative 1, 1, 1, 4, 3, 2, for example, right? In this case, we have a 1, 2, 3 row. 그렇죠? 3 rows, and we have a 1, 2, 3, 4 columns, right? 4 columns, right? So in this case, this size of this matrix is 3, 5, 4. 3 by 4. 3 by 4. In general, the m by n, I mean the m times n matrix looks like this, m rows and n column. Or we can say that m by m matrix is a rectangular array of the numbers, I mean the just values, with n rows and n column. This is definition of the size of your matrix, Maybe some of you are confusing what is the row and what is the column, because maybe this is going to be column or this is going to be row. So I would like to show you this page. So when you Google the column, the text column looks like this, and you can find out this kind of images. So the column means just like this one or this one. 이 한국말로 뭐라고 하더라? 이게 뭐죠? 이런 기둥을 뭐라고 하는데? 기둥, 아무튼 이런 기둥을 이제는 우리가 컬럼이라 부른다. 그래서 that's why we call this one as a column. This one is a column. That's why. Anyway, so this is the definition of the 열. 맞아요, 열. 컬럼. 로우는 한국말로 행이라고 그러죠. 행 in Korean. Anyway, this is definition of the matrix and size of matrix. Okay, people keep moving. I'd like to show you this page. So far, we discussed the matrix. Looks like this. 8 times 8 or the 8 by 8. So in this case, our input looks like 8 by 8. 8 rows and 8 columns. But when we just have the one column, but multiple rows, for example, 64 and 0, we just say that this is a vector. This is a vector. And what about this? If there is one more axis, for example, 4 by 4 by 4, 4 by 4 by 4 in 3D space, we often call this representation as tensor, but there's no strict difference between the vector, matrix, tensor, but it's just definition. It's just definition in terms of the number of axes. So 1D, 2D, and 3D cases. Anyway, we just talked about these 2D cases, and we will talk about this 2D matrix case in this semester, in this course, but we just to simply extend this kind of concept to the 3D matrix case, which is called the tensor. The reason I introduced this tensor is to show you some kinds of pages like this. As you know, I'm working in the computer vision field and team learning field. Maybe most of you already very well known about the team learning or the AlphaGo or some kinds of the neural network. Anyway, the tensor, this kind of tensor is just the core technique in the core representation is the team learning. So here are some examples here. Here's the example. So this is called the bridge network, which is developed to classify your input images as a class label. This is the network architecture. The network architecture for this bridge network. these figures are coming from the original papers. So when you check this figure, there are some notation, very familiar notation. So 112 by 112 by 112, 112 by 112 by 128. So, or 56 times 256 looks like this. So this kind of representation is the tensor. Okay. When we check another network, which is called the residual network. By the way, residual network is one of the most cited paper in the whole area, including the not a computer science department, but some electrical engineering or the biomedics or the informatics. Anyway, among the whole possible disciplines, this residual network paper is the most cited paper in last year and 2 years ago. Anyway, this is the core technique of the deep neural network. Anyway, when you check this page, this network architecture, it consisting of some kinds of the tensor, 3 times 3 times 64 looks like this. Anyway, we can say that the tensor is the core representation in the deep learning. 한국말로 더 설명해 주면은 뭐 오늘 첫 시간이라서 뭐 너무 깊이는 안 들어갔지만 쭉 얘기를 하면서 이제 매트릭스까지 설명을 했고, 이 매트릭스라고 하는 게 사실 2D에서 우리가 정의를 내리고 앞으로 계속 2D에서 얘기를 할 거지만 이게 이제 이렇게 3D나 1D로 확장했을 때 벡터 또는 텐서로 불리기도 한다. 그리고 이 3D 이상 4D, 5D 등등도 그냥 다 텐서라고 부르긴 하는데, 어쨌든 요게 사실 이제 우리가 뭐 많은 분야 중에 인공지능 분야로만 봤을 때는 그 인공지능의 어떤 뉴럴 네트워크라고 하는 하나의 단위를 표현한 레프렌테이션이 바로 이 텐서다라는 거죠. 무슨 얘기를 하고 싶은 거냐, 이제 우리가 열심히 오늘도 solving linear system equation들을 배우고 이제 이번 학기 통해서 열심히 매트릭스를 어떻게 잘 다룰까, ax equals b를 어떻게 잘 다룰까를 배우는 게 결국에 이런 데 쓰일 수 있을 거다라는 거죠. Extending 2D representation to the more high dimensional space is going to be straightforward, right? So that's why we take this course, this linear algebra course, and study this one, okay? Anyway, let's go back to the slide. Okay. So, how to find out the solution set of the system? What is our strategy? What is our strategy? You already know this strategy. 연립방정식이죠. 한국말로 연립방정식을 푸는 법 여러분 배웠지만, let's think about more systemic way to solve this linear system. Our philosophy is like that. By replacing one system with equivalent system, that is easier to solve. Okay, here's the one linear system. Here's another example. Another linear system. Okay, the solution of the first linear system is x1 is equal to 1. x2 is equal to -1, right? And solution set, the solution of the second linear system is x1 is equal to 1 and x2 equal to 2 as well, right? So in here, we can say that these two linear systems are equivalent system, right? Equivalent, or this second system is the equivalent system of the first linear system, right? So, okay, let's say this is the linear system 1 and linear system 2. So, in this case, which linear system is much easier to solve? Which linear system is easier to solve? Linear system 1 and linear system 2. Why? Why? 왜 그렇죠, 여러분? It's already given, right? Right. It's more simple. Coefficient is simple. You're right. So we will talk about which linear system is much easier to solve. But in this case, we just think about this is the more easier to more easy system to solve, right? Then our strategy from now on is how to make original linear system to equivalent system that is easier to solve. This is our strategy, and this is the topic of the today's lecture. This lecture. Okay, so to understand this one, let me show you the one example. The question was solving the given system of equation. Looks like this. We have a linear equation 1, 2, 3, and 3 coefficient, x1, x2, and x3. Solution is we have to find out x1, x2, and x3, right? So, okay. So first of all, let's draw coefficient matrix of this linear system. Because here's 1 and 0. So our coefficient system, coefficient matrix should be coefficient matrix should be 1, 0, 1, -4, -2, +2, 5, 1, -8, 9, 0, 8, -9. Right? Then let's think about how to solve this one. So here I will use the very simple way you already know, which is called 가감법 in Korean. 가감법. 그렇죠? 여러분들 배웠던 거 있죠? 중학교 때 배웠나? 그렇죠? 가감법. I will show you this kind of the technique to solve this problem first, and we will revisit this kind of the solving technique in a matrix form. Okay. Professor, it is the 맞아요. 말은 Augmented Matrix 그 같은데. Augmented Matrix죠? Thank you very much. Augmented Matrix. 그렇죠? 여러분 글씨 읽을 수 있겠죠? 이거 좀 더 천천히 써줄까요? 읽을 수 있죠, 여러분? 사실 필기보다 이해하는 게 더 중요해서 필기는 금방 후다닥 하는데 혹시 잘 안 보이면 얘기해줘요. 알았죠? Okay, so let's solve this linear system. So in this process, the elimination procedure is shown with and without matrix notation. Looks like this. The results are placed side by side for comparison. So we will solve this linear system here, but let's just check which matrix can be correspondence can be the corresponding one. Okay? 그래서 이제는 우리가 이제 요거를 푸는 거를 우리가 계속 공부할 건데, 이제 계속 보여줄 건데, 한번 요 모양이 어떻게 바뀌는지를 계속 좀 한번 제대로 봐요. 알겠죠? 그럼 이제 우리가 let's revisit this solution. Okay. So first of all, we will say that this is the equation 1, equation 2, and equation 3. How to solve this problem? Because we already have the x1 here, so our strategy is to eliminate this one and this one, right? This is our strategy, right? Because this is already 0, then we want to eliminate this term, -4x1, -4x1. How can you do that? To do so, add 4 times equation 1 to the equation 3. 4 times equation 1 to the equation 3. In Korean, 뭐예요? equation 1에다가 4를 곱해서 equation 3에다가 더해주면 저게 없어지죠. 그렇죠? 뭐 이런 건 너무 여러분 잘 알죠? 우리 벌써 다 아는 거죠? 그래서 x1, 2x2 plus x3 is equal to 3 was original first equation. I multiply 4, we achieve this linear equation, and this is original equation 3. 그렇죠? Then if I just add these two terms is going to be eliminated, and we will achieve the negative 3x2, 13x2, x3 is equal to negative 9. It's negative 2, negative 9. This is our new equation, right? The result of this calculation written in place of the equation 3 looks like this, right? So comparing to the original linear system and comparing to the original linear system, now we have another linear system looks like this, right? Note that we have a 0 and 0 in this term, right? So our augmented matrix, corresponding augmented matrix is going to be looks like this: 1, 0, 0, negative 2, 2, negative 3, 1, negative 8, 13, 0, 8, negative 9, right? Okay. And then what should be our next strategy? What should be our next strategy? In the next, we want to eliminate this one. So we want to eliminate this one by using row 1, first equation or the second equation. We want to eliminate this equation, this term, negative 3x2, right? How can you do that? Multiply equation 2 by 1/2 in order to obtain the 1 as coefficient for the x2. 그래서 뭐예요? Here 2x2 써볼까요? 그냥 2x2 negative 8x3 is equal to 8이었는데 just multiply by 1/2, then we achieve the new equation x2 minus 4x3 is equal to 4 to obtain 1 as a coefficient for the x2 here. 그렇죠? 여기를 1으로 만들기 위해서. 그 다음에 뭐예요? 이거 가지고 이거 지우려고 하는 거죠. 그렇죠? And then use x2 in equation 2. 그렇죠? equation 2니까 to eliminate 3x2 in equation 3. 그래서 here by multiplying 3, we have 3x2 minus 12x3 is equal to 12, and original x3, the original third equation was negative 3x2, 13x3, which is equal to negative 9. Then by just adding these two terms, the coefficient of x2 is going to be 0. Then we just achieve x3 is equal to 3. x3 is equal to 3 equation, right? In this case, here, in this linear system, corresponding coefficient matrix looks like this. 그렇죠? 이렇게가 되는 거. 일단 보기만 해요. coefficient matrix는 이렇게, 미안, augmented matrix. 그렇죠? augmented matrix 이렇게 된다. 그렇죠? What are you gonna do next? Now we have a new linear system having triangle form looks like this. 그렇죠? Because we eliminate this term, and this term. We now have a triangular form now. Why do we make original system in a triangular form? Because this matrix is easier to solve, right? This matrix is easier to solve comparing to this matrix, original matrix, original system, right? That's why. And in this case, augmented matrix looks like this: 1, -2, 0, 1, 0, 0, -2, 1, 0, 1, 0, 4, 1, 0, 4, 3, right? Then to find the solution, we already know the x3 is equal to 3, and we want to know the x3, x2, but we just assume that by removing this term, we can find out the solution of x2, and by removing these two terms, we can find the solution of the x1. In other words, our next strategy is to eliminating the above of the visible coefficient, visible term x2, x3, x3 and x2 like this. So specifically, now we want to eliminate -2x2 from equation 1. 그렇죠? 이거부터 해볼까요? 그러면 but it is more efficient to use x3 in equation 3. 그렇죠? 여기 to eliminate -2x3 and x3 in equation 2 and 1 by just multiply by 4, then add to achieve the new equation 2. So this one is coming from the equation 2, and when we multiply the third equation by -1, it's going to be 뭐예요? negative x3 is equal to -3, and original equation 1 also looks like this. Then by adding these two terms to equation, we achieve x1 minus 2x2 is equal to -3. 2x2 is -3. This is the new equation 2. 그렇죠? New equation 2. And combine the result of these two operations, then we have a new linear system. x1 minus 2x2 is equal to -3, x2 is equal to 16, x3 is equal to 3. Then corresponding augmented matrix looks like this. The last terms here, 그렇죠? Last term here. Then how can we do that? How can we solve this one? We can use second law or the third law. I mean the second equation or the third law. Third equation. Move back to the x2 in equation 2 in this case, and use it eliminate the -2x2 above here. So there is no arithmetic involving the x3. So 뭐예요? By just add 2 times equation to the equation 1. 그래서 그럼 굳이 풀어보자면 x1 minus 2x2 is equal to -3. 2x2에 뭐예요? 32, 그렇죠? 32니까 이거를 더해주면 x1 is equal to 29이 나온다. So our final linear system is going to be looks like this, and augmented matrix looks like this. Okay. So first of all, to check this one is the solution of our original system. How can they prove this one is the solution of our original system? How can they prove? 어떻게 알아요? 얘가 진짜 오리지널 솔루션인지 어떻게 알아요? 데이브. 그렇죠. 그렇죠? It related to the definition of the solution. The solution means solution should make original system, I mean the original linear equation, each linear equation, a true statement, right? Okay, let me check. So we can say the solution is 29, 16, 3. To verify this, substitute these values into the left-hand side of the original system and compute. 그래서 original system이 뭐였어요? x1, 2, negative 2, 2, negative 2x2 plus x3 is equal to 0. 2x2, negative 8x3 is equal to 8. 4x1 plus 5x2 plus 9x3 is equal to negative 9. 이 오리지널 시스템이었는데 by substitute this value to here, when we compute the blah 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 blah, it's going to be exactly the same. 해봐요 여러분들이. 이거는 복잡했는데 해봐요. 하면은 0, 8, 네거티브 9 나와서 리니어 시스템을 만족한다. 그렇죠? The result agree with the right-hand side of the original system because the original system was right-hand side of the original system was 0, 8, negative 9. So it's going to be exactly the same. So we can say that this is the solution of linear system. This linear system. When we plot this linear system, because this is the three variable case, each equation is going to be the plane, as we discussed in the first page. So when you assume that here is x1 axis, x2 axis, x3 axis, each linear equation here in original system, 그쵸? Each linear equation corresponding to the each plane looks like this, this, and this. Then the solution means 29, 16, 3 means the intersection of these three planes. Intersection of this plane. In other words, each of the original equation determine a plane in 3D. The solution is intersection with this plane. So here in this figure, we can just think of it's going to be really challenged to find out the intersection of the plane, even in three-dimensional case. I mean the 3D, the three-axis case. But what if we have the more variables, something like the x4, x5, and x100? It's going to be impossible to find the solution by just plotting, by just drawing this kind of the images. I mean this kind of plane. And we can say that it's going to be a really rare case. This three plane has exactly one intersection. Maybe in most cases, this kind of the plane does not have any intersection or just a partial intersection. So we can just think of the linear system having exactly one solution. It's very, very rare case. In real system, the real application, it's going to be impossible in some cases. 이제 여기를 보면서 이제 여러 가지 얘기를 할 수가 있는데, 우리가 열심히 리얼 시스템을 그래서 이제 인터섹션을 찾아보면 이렇게 솔루션이 되는데, 요거만 봐도 쉽게 생각할 수 있죠. 요걸 플레인을 3개를 그려서 인터섹션 하나가 나올 확률은 사실 뭐 정말 희박할 거예요. 그렇죠? 왜냐, 이걸 대충 그려도 우리가 세 플레인 한 점에서 안 맞거나 뭐 자기들끼리 만나거나 어떤 플레인들끼리 막 평행하거나, 그렇죠? 이게 3개의 베리어블 때만 해도 이런데 이게 베리어블의 개수가 늘어가거나 시스템이 커지면 exactly one 솔루션을 찾는 건 사실 불가능하다. 그리고 exactly one 솔루션을 가지는 경우도 거의 없을 거다. 라는 걸 우리가 이 그림을 통해서 아주 대충은 예측할 수가 있겠죠. 그리고 두 번째로 이제 더 이상 시스템이 커지는 순간 우리가 예전에 중학교 때 고등학교 때 하는 것처럼 이렇게 플라팅을 해서 더 이상 그릴 수가 없는 수준일 거다. 3D 이렇게 어려운데 라는 얘기를 해주고 싶은 거죠. 그렇죠? Anyway, let's go back to our solving linear system. So anyway, we just solved the equation, example 1. We just solved the example 1 by using some kinds of technique starting from here to here, here, here. In fact, this kind of the solution technique, a solving technique, it's not that easy that we that we get as we guess, because at each step, I mean the step, this is a step 5 and this is step 6, and each step we have to think of which variable, I mean the which term should be eliminated, right? So it's going to be the really challenge when we are considering the much higher dimensional linear system. So that's why, that's why we introduce augmented matrix like this one and this one. So from now on, we will revisit the solving technique in a matrix domain, within a matrix form, which is going to be much easier to understand and much easier to solve your linear system in a systemic way. 그래서 이제 사실 이게 오늘의 주제예요. 요거 푸는 거야, 여기 푸는 거 사실 여러분들 이거 푸는 거 못하는 사람 아무도 없죠? 그렇죠? 못하는 아무도 없는데 사실 이게 중학교식으로 풀기에는 이제 우리가 다뤄야 될 시스템들이 이렇게 많아야 5개 베리어블이고 뭐 이퀘이션이 5개고 이런 수준이 아닐 거예요. 우리가 이제 다루는 시스템들, 아까 저희가 딥러닝 얘기해 주셨는데 딥러닝에 다뤄야 되는 이 베리어블은 거의 몇백만, 몇천만까지 가요. 그런 것들 사실 이렇게 주먹구시를 못 풀죠. We need more systemic way to solve this linear system. 그렇죠? 우리 이제 조금 더 시스테미컬한 solving 테크닉이 필요한 거고, 그렇기 때문에 이제 이러한 것들을 어떤 이 augmented matrix 도메인에서 풀어내는 것들을 이제 우리가 배우는 거죠. 그렇죠? 그게 이제 바로 리니어 알제브라를 우리가 배우는 이유기도 하고요. 그렇죠? Any questions so far? What time? 6:08. Okay. Any questions so far? 자, 이제 오늘 수업이 거의 마무리가 됐는데 혹시 오늘 배웠던 것 중에 질문, 오늘 배웠던 거 너무 쉽죠? 그렇죠? 질문 있는 분은 question in English or Korean? 뭐 영어 한글 괜찮으니까 혹시 오늘까지 배웠던 것 중에 질문이 있을까요?
저기 혹시
네.
네네 아까 그 텐서라는 거를
네.
잠깐 알려주셨는데 혹시 그거를
네.
이번 수강에서 혹시
네.
배울 건가요? 그 수학적으로?
안 배웁니다. 왜냐면 그래서 제가 여기 봐봐요. 여기 서플이라고 써놓는 거는 서플멘터리라는 뜻이에요. 그냥 그래서 요거는 이런 게 있다 정도만 여러분들이 알면 돼요. 텐서는 저도 잘 몰라요. 너무 복잡해서 사실 이건 손으로 못 풀어요. 어차피. 그래서 이건 어차피 여기서부터는 다 우리가 이제 어떤 컴퓨터 툴로 사실 거의 다 처리를 하죠. 근데 우리가 걔네들이 어떻게 돌아가는지 알려면 이 2D 스페이스에서만 이해를 하면 돼요. 그렇죠?
네, 알겠습니다.
네. 형민 학생 질문이 too many variables에 대해서 설명해 주세요. 이런 거예요. 예를 들어서 우리가 이걸 생각해 봅시다. 매트릭스. 이 매트릭스 생각해 봅시다. 그렇죠? 이 매트릭스 생각해 보면 뭐예요? 얘 매트릭스는 값이 땅땅땅땅땅땅땅땅땅땅땅땅땅 값이 있고 이게 뭐 112개의 row와 112개의 컬럼으로 이루어진 값이에요. 그렇죠? When you consider this matrix as an augmented matrix or the coefficient matrix, we just consider at least 112 variable, 112 variable. So it's going to be really, really high dimensional, high dimensional input. 그래서 이제 이런 거 보면 이런 경우는 보면 우리가 오늘 방금 풀었던 문제는 시스템 3개의 베리어블 3개인데 그럼 3x3 매트릭스죠 사실 코피션 매트릭스가. 근데 이런 건 보면 뭐 112 다 112예요. 이것도 작은 거고 실제 이걸 다 한 번에 풀려고 하면 몇 천만 바이 몇 천만의 매트릭스가 되는 거죠. 그렇죠? 그런 경우가 이제 우리가 훨씬 더 풀기 어렵고 이제 더 시스템과 웨이를 갖지 않으면 사실 풀 수가 없다라는 걸 얘기해 주고 싶었던 거예요. 알겠죠? Professor, is possible to have answer in question in English as well? Yes. Okay. So the question was, what is the meaning of too many variable? So I just show the examples here. When you just considering this kind of the matrix, in this case, 112 by 112 matrix. The size of this matrix is 112 by 112. So in this case, we have a 112 variable x1, x2, blah blah blah, x112, right? So in this case, it's going to be extremely challenging to solve linear system. That's why we need a more systemic way to solve this kind of linear system. And the next question was, if we consider the matrix and coefficient matrix, too many variables. Right, exactly. Any question? 선호 학생 질문이 Augmented Matrix가 있는데 왜 Coefficient Matrix가 필요한 건가요? It depends on your application. In some application, you may not have the right-hand side values of your linear equation in your linear system. In this case, you have to consider only coefficient matrix to solve your linear system. Okay, and that's it. In introduction, I mean the last week introduction, I told you I will briefly summarize what we've done so far in Korean in every at each class. But today, I think I just mentioned some kinds of concept in Korean again. So we'll skip this one today. 근데 여러분들 제가 뭐 원래 강의가 다 끝나고 한국말로 한 번씩 서머라이즈 한다고 했는데 오늘은 중간중간에 필요할 때마다 서머라이즈 하신 것 같아서 오늘은 그냥 넘어갈 거고요. 더 강의 포맷은 약간 이런 식으로 계속 진행이 될 거예요. 제가 영어로 좀 설명해주고 조금 필요한 거 있으면 한글로도 설명하고 여러분들 질문도 해주면 좋고요. 그렇죠? 그래서 이제는 이렇게 할 거고요. Okay, so this is the end of today's lecture. On third day, we will talk about how to solve this linear system in a matrix domain by using some kinds of elementary law operation. We will talk about this one in third day. Okay, that's it. Any other question? No? Okay, so that's it. So this is end of today's lecture. Thank you very much. Let's see on this Thursday. 여러분들 오늘 수고하셨고요. 우리 이제는 목요일 날 다시 보도록 하겠습니다. 고생 많으셨습니다.